Anytime something is moving in a circular path, there has to be a force toward the center of the circle. And we just give it a special name. We call it centripetal force, but it's not a new force. There's no such force called centripetal force. It's a special name we give to forces that we already know about. So let's take a look at this example. We're up in a helicopter looking down on a circular track, and there's a car driving around. I have a little blue square there. That's my car, and it's driving in this direction. But the car doesn't just go straight. The car is moving in a circle. So the car is going to end up over here, and then it's going to keep going, and it's going to end up over here, and it's going to keep going, and it's going to end up over here. It's going to stay on this circular track. Well, the only way it can stay moving in a circle like that is if there's a force acting on it toward the center of the circle as it goes around. And what's the only force acting on the car? Friction between the tires of the car and the road. So it's the friction force that's keeping the car moving in a circle, pushing inward on the car as it goes around. Think about this for a second if you're having a hard time grasping that. Let's say the car is coming along and there's a spot here. There's a spot here where there's ice. No friction there. And the car is coming along, driving along, and the car gets to this spot and it's coming in this direction. What's going to happen to the car when it hits that spot with no friction? It's going to go straight across whatever direction it was going when it came into the ice. It's just going to keep going straight in that direction, and the car is going to end up over here, not on our track, not on our circular track. So that might help you picture how friction is keeping the car moving in a circle. Think about what would happen if the friction wasn't there. The next part of the question asks what happens to a satellite going around the Earth. So I've drawn my Earth, and that's as close as I can come to drawing a satellite. So there's our satellite, and it's going in a circular path around the Earth, like that. How is it doing that? Well, the satellite has some kind of a speed in this direction. It's moving in that direction, but a force acts on the satellite, and it ends up over here, moving in this direction. And a force acts on the satellite, and it ends up over here, moving in this direction. And the force acts on the satellite. And what is that force? What's the only force acting on that satellite as it goes around the Earth? Gravity. The force of gravity between the satellite and the Earth is pulling the satellite toward the Earth. And if we could magically turn gravity off at this instant, right here, what would happen? The satellite is moving in this direction, and if this force went away, it would just keep moving in that direction forever. Then the next part of the question asks about a roller coaster doing a loop-the-loop. So if a roller coaster car is coming along here, moving in this direction, and it goes up the loop, what must be happening? Something must be pushing toward the center of the circle, changing the direction of the car. And when it's at the top, it has to be pushing down on the car so that when the car gets over here, it changes direction. And something pushes in towards the center of the circle, and the car changes direction. And it's always moving forward. The car is always moving forward, but there's a force toward the center of the circle causing the car to change direction. So that's an interaction with the track. The track is pushing in on the car towards the center of the circle, and that is the centripetal force.